Imagine looking up at the night sky and realizing that everything you can see, every star, every galaxy, every glowing nebula, accounts for less than 5% of everything that exists. The rest? Dark, invisible, unknown. Scientists call it dark matter. And despite decades of research, the brightest minds on Earth still have no idea what it actually is. But here's what makes this truly unsettling. We know it's there. We can feel its gravity pulling on galaxies across the universe. We just can't see it, can't touch it, can't explain it. Tonight, we go into the dark. To understand why dark matter keeps physicists awake at night, we need to go back to 1933. A Swiss astronomer named Fritz Zwicky was studying the Coma Cluster, a massive group of over 1,000 galaxies sitting 320 million light-years away. He did something simple. He measured how fast the galaxies inside the cluster were moving, and the numbers didn't make sense. The galaxies were moving so fast that, by all the laws of physics, the cluster should have flown apart millions of years ago. The gravity from all the visible matter, all the stars, all the gas, all the dust, wasn't nearly enough to hold it together. Zwicky concluded that there had to be something else, something invisible, something massive. He called it Dunkel Materie, dark matter. For decades, nobody took him seriously. Then, in the 1970s, an astronomer named Vera Rubin changed everything. Rubin was studying the rotation of spiral galaxies, galaxies like our own Milky Way. In a normal galaxy, stars near the outer edges should orbit more slowly than stars near the center, just like the outer planets in our solar system orbit more slowly than the inner ones. But that's not what she found. The stars at the edges were moving just as fast as the ones near the center, sometimes even faster. The rotation curves were completely flat. The only explanation: there was a massive invisible halo of matter surrounding every galaxy. Matter we couldn't see, but whose gravity was holding everything together. Dark matter wasn't a mistake. It was a fundamental feature of the universe. So what exactly is dark matter made of? This is where things get strange, because after nearly a century of searching, we still don't know. We know what it isn't. It isn't regular matter, protons, neutrons, electrons, the stuff you and I are made of. It doesn't emit light, reflect light, or absorb light. It passes through ordinary matter like a ghost through a wall. The leading candidates are particles called WIMPs, weakly interacting massive particles. The theory goes that billions of these particles are passing through your body right now, every second, without you feeling a thing. To detect them, scientists built one of the most extraordinary experiments in human history. Deep beneath the Black Hills of South Dakota, inside a former gold mine, sits a tank filled with 10 tons of liquid xenon, chilled to nearly absolute zero. It's called the LUX-ZEPLIN detector. The entire apparatus is shielded by a mile of rock above it. Rock that blocks out almost every particle in the universe. Almost. If a WIMP were to collide with a xenon atom, it would produce a tiny flash of light. Just one flash. That's all scientists are looking for. So far, nothing. The experiment has been running for years. The detector is sensitive enough to detect a single photon, and the WIMPs refuse to show themselves. But WIMPs aren't the only candidate. Some physicists believe dark matter could be made of axions, incredibly light particles originally proposed to solve a completely different problem in physics. Others believe it could be primordial black holes formed in the first fractions of a second after the Big Bang, before any stars existed. And then there are the more radical theories that challenge everything we think we know, because some physicists have started to ask a far more disturbing question. Here's the most unsettling possibility of all. What if dark matter doesn't exist? A small but growing group of physicists argues that we've been looking at this all wrong. Instead of adding invisible matter to make the equations work, maybe the equations themselves are wrong. Maybe gravity behaves differently at galactic scales than we think. This theory is called MOND, modified Newtonian dynamics. And while most physicists reject it, it has one thing going for it. It accurately predicts the rotation curves of galaxies without invoking a single particle of dark matter. But MOND has its own problems. It struggles to explain the Bullet cluster, two galaxy clusters that collided 150 million years ago. When they smashed together, the hot gas from each cluster slowed down and clumped in the middle. But the gravitational center of each cluster kept moving forward, as if pulled by something invisible that passed right through the collision without slowing down. That invisible something behaved exactly like dark matter. In 2006, astronomers mapped the distribution of dark matter across a large region of the sky using gravitational lensing, measuring how massive objects bend light around them, like a cosmic lens. What they found was breathtaking. Dark matter doesn't clump randomly. It forms a vast cosmic web, a network of invisible filaments stretching across the entire universe, hundreds of millions of light-years long. Galaxies don't float freely in space. They sit at the intersections of this web, like droplets of dew on a spider's thread. We live inside a structure we cannot see. If dark matter is real, and most evidence suggests it is, its discovery would be one of the greatest moments in human history. But consider the multiverse hypothesis. Some physicists believe our universe is just one of an infinite number of universes. In this framework, dark matter particles might actually be ordinary matter from a parallel universe, leaking gravitational effects into our own through extra dimensions of space. We wouldn't be able to see it because it literally exists in another universe. We only feel its gravity because gravity can leak between dimensions. Some researchers have also proposed that periodic extinction events on Earth, mass die-offs every 26 to 30 million years, could be caused by our solar system passing through dense regions of the dark matter halo, sending showers of comets raining down on our planet. Dark matter may have shaped the history of life on Earth. We are made of the rarest stuff in the universe. The atoms in your body, the carbon, the oxygen, the iron in your blood, make up less than 5% of everything that exists. The universe is mostly dark, mostly unknown, mostly something we have no name for. Dark matter doesn't emit a signal. It doesn't want to be found. It has been hiding in plain sight since the beginning of time, shaping galaxies, threading the cosmos into webs, and possibly reaching across dimensions we can't access. And here's what should keep you up at night. We've been searching for 90 years. We've built detectors buried under mountains. We've pointed the most powerful telescopes ever constructed directly at it. We've thrown the full weight of human intelligence at the problem, and it hasn't blinked. Whatever dark matter is, it is profoundly, stubbornly, almost deliberately invisible. Next time, we go even deeper. If 27% of the universe is dark matter, what about the other 68%? Dark energy, the force that is tearing the universe apart, is even more mysterious, and its discovery may change physics forever. If that sounds like something you need to know, subscribe. The universe isn't done with its secrets.